factored, so we might as well use the factored form, right? And just like we've been doing, just set your factors equal to 0 and solve. So we get -9 over 11. We get +9 over 11. If you want to write those answers as plus or minus 9 over 11, that is fine. B equals. Okay, I'm not going to go through checking it. I'm confident that I can add or subtract 9 and divide by 11. Here's the other way that you can do it. Because this equation has one single variable. It has one single variable in it. Technically, we can approach this from the perspective of, well, I can just isolate that variable. I can add the 81 to the other side. I can divide both sides by 121. So I get 81 over 121. That may reduce. I'm not going to worry about it, though. And then take the square root. So B equals plus or minus. Square root of 81 is 9. Square root of 121 is 11. Now, the reason why I don't have a problem with you doing this, but most people, when they take that square root, guess what they forget? The plus or minus. So they only get the positive solution. They forget about the negative solution. If you factor it, you're guaranteed to have both of them. Okay? So I don't have a problem if you want to solve this by taking square roots, as long as when you take the square root, you remember to include the positive and the negative. Okay? And again, it's a quadratic equation. It should have two solutions. So if you solve that and you only get positive 9 over 11, you need to be thinking, what am I missing here? Oh yeah, I took a square root. I need to remember the negative. Now, number 8, I don't have a factored form on number 8. Why do I not have a factored form on number 8? Yes, Sam.
I got a question.
Okay, yes.
For, like, your final answer,
Yes.
do you always put like plus or minus?
You can write them separately if you want to. That's fine. It's just the shorthand if you do the plus or minus in front of the fraction. Okay, I'm good with either one. All right, number 8. Why do I not have a factored form? It's not the difference of perfect squares. There's a plus right here. So it was not factorable, but that doesn't mean that it's not solvable. Okay, we can still solve this just using the method I just showed you, square roots. Isolate the variable because we only have one variable. So subtract the 9 from both sides. Here's why it was not factorable, because when we take the square root, we have a negative underneath the square root, so our answers are imaginary. So plus or minus, 9 is a perfect square, so it's 3. But it's 3i because we took the square root of -9. So plus or minus 3i are the solutions to this one. We can check it, just like we've been checking it. Store 3i as x. 9 plus x squared is 0. Okay, we can do the same thing with -3i, but if positive 3i works, -3i is going to work. Okay? Questions? Okay, really quickly. Number 9, just make sure we've got it. We've got it in factored form. This one had a GCF, so 6 can't equal 0. I'll write it down anyways, though, and mark it out. 9p plus 1 equals 0. 9p minus 1 equals 0. So 9p equals -1. Divide by 9. P equals -1 over 9. Add 1. Divide by 9. P equals +1 over 9. You can write them separately, or you can shorthand it, plus or minus 1 over 9. So quadratic, so we expect two answers, positive and -1 over 9.